Hello, today we'll be using the basic math operators. Create two numbers. And we'll print their sum. The plus operator adds two ints or an int with a float. The float class has the same operator. Right can be int or float. Now pay attention. The result will be int only if both numbers are int. We can add an int with a float, but the result is float, even if the argument was a whole number. The addition in the float class will always return a float. Both return values are float. So if we run this, we get 10.0, a float. If number 2 was int, 10 is also int. Now, let's say we want to increase number by the value of number 2. We can just say number is number plus number 2. The single equal sign means assignment. So, number becomes number, 5, plus number 2, also 5. And now number is equal to 10. There is a shortcut for this, the plus equals. Now we no longer need to write number on the right side. And that has the same result. Now this one is not in the documentation, but you can combine a lot of the other operators with the equal sign. It works for most of the operators here. This one is usually seen in loops where we increase and counter. This line will increase the variable counter by 1. The plus operator can also be used on a single number. This is the unary plus operator. Returns the same value as before. It does nothing but make the code more readable. The same operator exists for floats as well, and does the same thing. As expected, the result is still 5. If we want our text to write plus 5, we can concatenate two strings. So this plus will appear in the label in front of this number. Plus 5. However, if the number is negative, we get plus minus. We can easily solve this with a ternary operator. Now if the number is positive, add a plus sign. Now it works correctly. Positive numbers get a plus. Also 0 takes no sign. Next up is subtraction. The minus operator subtracts right from the left. If right is float, result is float. We can also subtract ints to get an int. The float class has the minus operator as well, subtracts int from the float, and subtracts float from the float. This gives us 0 since the numbers were equal. Again, if both are ints, the result is just 0 instead of 0.0. Just like before, we can change the value of number. So this subtracts, and number is now the difference. So it becomes 0. Unlike before, the unary minus has an actual use. It returns a negated value. Positive becomes negative, negative becomes positive, 0 stays the same. Flows can do the same, positive, negative, negative, positive. The only difference is that 0 can be positive or negative. That affects 0 division. So, unary minus negates. If it's minus 5, we get 5. This works for floats as well. Minus 5. Now for 0, we get just 0. But if we divide a positive number by minus 0, we get negative infinity. If we divide just by 0, it considers it the positive 0, so we get positive infinity. More on division later. Now we're moving to multiplication. The asterisk gives us the product of two numbers. This one has quite a few cases. First, we'll see just numbers. If right is float, it returns float. If both numbers are int, the product is int. The float class also has the same operator. Both return float. We get 25. We can change the value of number to the product. And now number is 25. We can also multiply with vectors. We'll see them in another tutorial. For now, imagine vector 2 as a pair of numbers. To create a vector 2, we write its name and two numbers. This will multiply each number of the pair separately. So 1, 2 becomes 5, 10. The vector 2i is a special case where we only use integers. We get the same result but without decimal parts this time. There's also vector 3. That's 3 numbers. Let's pick a float this time. And it multiplies separately once again. Just like before, we have the integer counterpart. As you can see, the third product is 5 times 3 instead of 3.5, so we get 15. Then we have vector 4, works the same. Vector 4i. And there's 2 more. The quaternion, which is useful for rotations. We won't really get into details. Imagine it like a vector 4 for now. So multiply with quaternion. It multiplies separately again. One difference you may have noticed is that not all numbers have a decimal point now. Last one is the color. This takes 3 or 4 numbers. Let's say 0.5 on red, 0.1 in green, and full on blue. Finally, set alpha to max. We can use this one to set the color of our label. Okay, the add theme color override changes the color of the label. We need the name, which is font color, and the color. Now we see it multiplies all 4 numbers by 5, even the alpha. Let's put the result in here. Change the green. Now we get values that are above 1. We don't really want that for the color. Its values are supposed to be between 0 and 1. To avoid that, we can use the club method. If we don't pass any arguments, it will ensure all values are between 0 and 1. So we'll never go beyond. The case of float multiplication is similar. Color works the same, quaternions work the same, vector 2 works the same, but vector 2i gives a vector 2. Let's use our float this time. The numbers have a decimal point now, which means this is no longer a vector of integers. The same goes for vector 3i and vector 4i. Now we move on to division. First of all, if both are ints, we get the quotient of the Euclidean division, if the dividend is positive. We'll see about the remainder on the next video. Let's use a division that's not perfect, 5 divided by 3. The result is 1. We also get a warning, integer division. Decimal part will be discarded. The actual result would be 1.666 and so on. If we turn 3 to a float, it becomes float division, and we get the correct value. If the dividend is negative, we get minus 1, because it's minus 1.6. The Euclidean division in this case gives a different result, because the remainder has to be positive. So we get minus 2. We can calculate this. Minus 6, minus 5. Oh, also, I use the evaluate selection for this. It does the math for you. Now let's make the divisor negative. Still minus 1. Euclidean division gives minus 1. If both are negative, we get 1. Two and 1. Evaluate, we get minus 5. So if one number is float, we get float even for perfect divisions. What happens if we divide by 0? We get an error. Division by 0 error. This is integer division. Both numbers were int. If the dividend is float, the result is always float. And something interesting is that float 0 is different. Add a dot to the 0. Now we get infinity. We can also get negative infinity if one of the numbers is negative. Infinity is a special constant we'll see in the future. So, what about 0 divided by 0? First of all, integer division. Error, same as before. Let's turn one of them into float. And we get none. It means not a number. We can use slash equals to store the result to the number variable. Let's divide it by 2. And we get just 2 instead of 2.5. First of all, we had an integer division. This will truncate the float. So let's turn 2 to a float. And we still get 2. That's because number is int. We'd have to change it to float to keep the decimal part. That was it for the basics. In the next video we'll see the mod operators. Till next time.